Good afternoon all and welcome to Caram Cymru revision sessions. This session this afternoon will focus on mathematics GCSE and will be presented by Mrs Dixon from Pentre Harvard School in Swansea. The session will last around 45 minutes where Mrs Dixon will run through the relevant subject content. If you have any questions, please use the question and answer section within the webinar, within the live event, and we'll endeavour to answer your questions during the session. The session will be recorded with the recording and any relevant resources uploaded to the e-sgol website within the Caram Cymru section. Diolch, Mrs Dixon, over to you.
Diolch. Okay, so we're going to look at types of numbers this afternoon, and these are the things that we're going to hopefully cover. So we're going to look at squares and square roots, cubes and cube roots, prime numbers, factors and highest common factor, and then multiples and lowest common multiples. So we're going to get going. We're starting with squares and square roots, and square numbers are going to be our first task. Okay, so a square number. Okay, this is the result of a number multiplied by itself. So for example, 1 multiplied by 1 gives you 1. So 1, the answer here is our square number. 2 multiplied by 2 is 4. So 4 is the square number. 3 multiplied by 3 is 9, and so on. Okay, and obviously this carries on. So the ones I've highlighted on the screen there are our first 4 square numbers. When we read them, we say 3 squared, 4 squared, 5 squared, and so on. But when we write them, we use this little power, and that power is a 2. Okay, so we have whatever number we're looking at to the power of 2, but we read it as 3 squared. So let's get going with some examples. Calculate each of the following. 10 squared. Okay, so we're using the language now that we should be using. So 10 squared. I'll just change myself to a pen. That means, as we've just seen on the last screen, 10 multiplied by 10. And we actually work it out. We don't leave it as 10 multiplied by 10. We work it out and you get your answer. So this answer is 100. Okay. Next one, exactly the same, 6 squared. So that means 6 multiplied by 6. And we work that out. And our answer is 36. Okay, so what I would like you to do now is have 30 seconds to try the 2 on the right hand side, and I'll set a timer now. Off you go. Okay, I'm going to come back in now. If you'd like longer, then please just pause the video and carry on. But I'm going to go through the answers with you now. So just like I've done on the left-hand side, 5 squared means 5 multiplied by 5, giving you an answer of 25. 9 squared means 9 multiplied by 9, giving you an answer of 81. Okay, so that's our square numbers. Right then, another question. I'm now giving you a list of numbers, and from that list, you need to identify the square numbers. If you'd like to have a go at this question on your own, please pause the video now. Other than that, I am going to start to go through it. So I'll give you a few seconds in case you do want to pause the video, and then I'll start. Okay, so we have a list that's given to us, and this is very similar to a lot of the GCSE questions that you see as well. And you've got to think about, are these square numbers? So it's going back to what I've done a couple of slides ago, where you're thinking about what makes a square number. It's a number that's been multiplied by itself and the answer you get from that. So this first one, we're thinking about, is it a number that can be multiplied by itself to give you 125? Now, what we can do to help us is actually think about the square numbers. We can start on, what is 1 times 1? It's 1. What is 2 times 2? 3 times 3. And we can list them, and then we can match up, are there any of these square numbers in this list above? So I can see now I've already got 1. So 1 is a square number. 4 and 9 not in my list, but 16 is, and I can keep going. So 2 is not a square number because it's not a result of a number being multiplied by itself. 8 is not, and obviously we've got to carry on. So 25 is the next square number, 36, 49, 64, and both 49 and 64 are in the list. So 20 I've gone past, that one's not, and then we've got a few more. So I'm going to keep going for a minute. So we've got 64, which came from 8 squared. So the next one is 9 squared, which is 81, 10 squared, which is 100, 11 squared, which is 121. Now that is in my list. Okay, so I'm going to circle that one. 12 squared is 144. Now then, so 125 I've passed, so that one's not. And then the only one I've got left now is 400. And I don't want to keep going all the way up to 400. So I want to think about, is there something I can break this down into to get some square numbers from this? So instead of having the number 400 as one unit, I could write that as 4 multiplied by 100. And if I think about, is there a number multiplied by itself to get 4? Yes, there is. It's 2. And I'm not going to use equals actually. So 2 is a square number, 4 is a square number, sorry, of 2. And 10 can be used there to get 100. So if I work out what 2 multiplied by 10 is, I get 20. And I can check that then. If I square 20, going back to the notation that we've seen before with a little power 2, that's the same as 20 multiplied by 20. And if I work that through, I do get 400. So 400 is also a square number in that list. Okay, moving on. So next part of within that is square roots. Now a square root is the reverse operation of squaring. So exactly the opposite of what we've just been doing. So here you're looking for what you multiply by itself to give you the number under the square root. So for example, to find the square root of 9, you'd need to think about what number you multiply by itself to get you an answer of 9. So we say the square root of 9, and there is a symbol that we use, and you can see it on the screen now. It looks like a little tick, okay, and it covers the number that you're talking about, and that then is the square root of 9, and that's the symbol that we use. So if you see that at any point, that relates to a square root. So let's go through a couple of examples. So the square root of 100. We are thinking about what do you multiply by itself to make 100. So doing the reverse operation of squaring, I realized that I can do 10 multiplied by 10, and that would give me 100. I wouldn't write 10 multiplied by 10 here. I would only write what the number is that I need to multiply by itself to get that 100. And then next one, the square root of 36. So it's looking for a number that you multiply by itself to get an answer of 36. And that number is 6. So just like we did with the square numbers, I'm going to give you 30 seconds to have a go with the 3 you can see over on the right, and then I'll come back into you. Okay, then if you'd like more time, please pause the video and have a go. So the square root of 1, what do you multiply by itself to get 1? The answer to that one was 1. Square root of 25, what number do you multiply by itself to get 25? It's 5. And then the last one, the square root of 144, what do you multiply by itself to get 144? You have 12. Okay. Lovely. Right, there's a spot the mistakes question now. Again, I would like you to pause the video once I've run through what you need to do. So we've got, can you spot any mistakes? And then I've got the question of right on the, oh, that should say value there, value of 3 squared. And we have 3 multiplied by 2 is equal to 6. And then calculate the square root of 64. And the answer that's given is 8 times 8. Okay. So if you'd like to have a go at this question yourself, please pause the video. I'll give you a few seconds to do that. Okay then, so what is wrong with them? So we are looking for mistakes. These answers that are given, there are mistakes in them. Now then, if we go back to the definition of squaring, squaring meant that we multiply by itself. So 3 squared should be 3 multiplied by 3, not 3 multiplied by 2. Now this is a common mistake. People see the 2 that we have as the power and then treat that as multiplying by 2. They are not the same, because if I work out 3 multiplied by 3, I get 9, which was not the answer that was given, which was 6. Okay, so squaring is not multiplying by 2, it's multiplying the number by itself. Part B, the square root of 64. Well, a number multiplied by itself that gives 64 is 8. However, 8 multiplied by 8 is not the square root of 64. If I work out the 8 multiplied by 8, I get 64, but that's not the answer to what the question was asking. What I should have had was just 8, not the times in by 8 as well. Okay, so only write down the value, not the calculation that was done to get that 64. Fab. Okay, so if I go back to what we were trying to do today, we've covered squares and square roots, and we're going to move on now to cubes and cube roots. So a cube number is the result of a number multiplied by itself twice. So this time we have more multiplying to do, but it's the same idea as squaring, but with that extra multiplying step. So 1 multiplied by 1 multiplied by 1 is 1. And 1 is a cube number. 2 multiplied by 2 multiplied by 2 is 8. So 8 is a cube number, and obviously that carries on then. So the ones I've highlighted, just like before, are the start of our cube numbers. Sorry, I'm on the wrong thing here. Let me just get back on to clicking off the pen. Right, so we say 4 cubed, and this time, instead of having the power 2, we now have a power 3. So the power 3 represents cubed, and we would read that. So if I had 4 with a little power 3, that is 4 cubed. And it means what I've got above, 4 multiplied by 4 multiplied by 4, giving me an answer of 64. Okay, so if I work out 5 cubed, I would be thinking that that means 5 multiplied by 5 multiplied by 5. And giving me an answer of, okay, let's do this in stages. So 5 multiplied by 5 is 25, and I've still got the multiplying by 5 to do that I haven't done yet. So 25 multiplied by 5 gives me 125, and that would be my answer for 5 cubed. Next one, 9 multiplied by 9 multiplied by 9. Okay, so 9 cubed. That gives me, first of all, 9 times 9 is 81. And then if I multiply by 9 again, now then I'm going to need to do a little calculation here. This would be sort of non-calculated, okay? So we look into how we would work this out. So I would use the grid method. If you've got a different method to use to multiply, that's fine. But I would work this out as 81 would be split into 80 and 1, so into our tens and units. And then I would have 9 here, and I would create a little multiplication grid that I would then work through. So I'm going to work out 9 times 80. I'm going to think of 80 as 8 times 10. So I'm going to do 9 times 8, which is 72, multiplied by the 10 as well, so 720. Then I'm going to work out 9 multiplied by 1, which is 9. And then to get my overall answer, I need to add these two together. So I have a final answer of 729. Okay, so you need to use some multiplication grid sometimes to do these as well. Okay, there are 2 questions over on the right-hand side. If you'd like to pause the video and have a go at those, I'm going to give you about 5 seconds to pause it, and then I'm going to carry on. Okay, so going through the answers to these questions then. 10 cubed means 10 times 10 times 10. And 10 times 10 is 100, times by 10 then is 1000. So 10 cubed is 1000. 7 cubed, 7 times 7 times 7. 7 times 7 is 49. And then I need to multiply that by another 7. So I'm going to do a very similar method to I did over on the left-hand side. I'm going to split the 49 into tens and units. And I'm going to create a multiplication grid that I'm going to fill in. So 7 times 4 times 10 is the way I'm going to think of this 40. So 7 multiplied by 4 is 28, multiplied by 10 is 280. 7 multiplied by 9 is 63. And then I need to add these together to get my answer. And when I add those up, I'll get 343. So 7 cubed, 343. Okay, and on to cube roots. So cube root, just like a square root, is the reverse operation of cubing, same as square roots with the reverse operation of squaring. So you are looking for what has been multiplied by itself twice to give you that number under the square root. And for example, to find a cube root of 8, we would need to think about what number you'd multiply by itself twice to get an answer of 8. So we say the cube root. And this time when we write it as a symbol, and you may see this in an exam as well, the way it's written, we have this little 3 next to what was the square root symbol, and that makes that a cube root. So if you see a little 3 in front of your square root symbol, it means cube root. Okay, so the cube root of 1000. So you're thinking about what number has been multiplied by itself twice to get that 1000. And sometimes with these it's a case of just practicing and going through them and saying, okay, well, 1 times 1 times 1, 2 times 2 times 2, and getting your answers and writing them down. And actually you'll get the answers quite quickly because the numbers go up so fast. So looking at that number, I can see obviously we've got a 1 and a few 3 zeros. I'm going to think that that number is 10, and I'm actually going to check that. I'm going to say, is 10 times 10 times 10 1000? And yes, it is, because 10 times 10 is 100, multiplied by another 10, I get my 1000. Okay, but the answer is actually just 10. Cube root of 64. So I need to think about what number multiplies itself to give me an answer of 64. And that answer is 4. And again, I'm going to do my check. So 4 multiplied by 4 is 16. And then if I multiply 16 by 4, well, actually timesing by 4 is the same as doubling and doubling again. So double 16 is 32, double 32 is 64. I'm happy that is my answer. So 4 is the cube root of 64. Okay, same as before, there are some questions on the right. I'd like you to pause the video and have a go, please. I'll carry on in a few seconds. Okay then, so going through the answers to these questions, I'm thinking about what are my cube numbers, 1 multiplied by 1 times 1 and so on. And the number that I need here is 3, because 3 multiplied by 3 is 9, 9 multiplied by 3 is 27. The next answer you should have had was 5. 5 times 5 is 25, multiplied by 5 again is 125. And question 3 links back to what we did with cubing, and we actually worked through this question for the cube numbers, and it is 7. So 7 multiplied by 7 is 49, and then 49 multiplied by 7 gives you the 343 under that square root then, cube root, sorry. Okay, so we've done the first 2. Our next little topic is prime numbers. So a prime number is a number greater than 1 that has exactly 2 factors. Okay, and that bit is really important. It has to have exactly 2 factors. The number 1 and the number itself. Now we need to think about what these factors are first of all. So before we get fully into prime numbers, let's just think about what a factor is. So a factor is a number that divides exactly into another number without leaving any remainders. Now, for example, the factors of 20, and I've listed them here for you. They're 1, 2, 4, 5, 10 and 20, because these are all the numbers that divide exactly into 20 and they don't give any remainders for that. Okay, so back to our prime numbers then. So for example, 3 is a prime number as it only has 2 factors, and those factors are the number 1, which has to be there, and whatever the number is itself, which in this question is 3. So because 1 and 3 are the only factors of 3, the only numbers that divide into 3 exactly, that 3 is a prime number. 11 is another example of a prime number. Okay, that's another number that only has 2 factors, and that is the number 1 and the number 11. And then an example of not a prime number, okay, is 15, because it has more than 2 factors. So only has to have 2 factors, 1 and the number itself. So 15 also has, they do have 1 and 15, but it also has 3 and 5 as well. And because there are more than 2 factors, that one is not prime. So a question to you, is 1 a prime number? So I'm going to let you have a think for 10 seconds. Okay then, so 1 is not a prime number. Okay, some people think that it is, it's not. If we go back to the definition right at the top, it says it has to have exactly 2 factors. Now the only number that goes into 1 is 1, so it only has 1 factor, which means the 1 is not a prime number. Okay, so that one might be useful to you as you go through. Okay then, so we have a list again. So which numbers in the following list are prime numbers? So you've got to think about this as, are there any numbers that can go into the numbers you can see that are not 1 and not the number itself? And if there is, then they're not prime. So if I can find a number that goes into 4 that's not 1 or 4, okay, 4 is not a prime number. So a number that goes into 4 is 2. So the factors of 4 are 1, 2 and 4. It has 3 factors. That one is not a prime number. Moving across to 7. The numbers that go into 7 exactly without any remainders are 1 and 7. There are no other values that go into 7, so that one is a prime number. Factors of 10, okay, so numbers that go into 10. So 1 and 10, obviously. But it's an even number, okay, and there's only one prime even number, which I'll go through in a minute. But if it is, then 2 obviously goes into it, and as soon as I get to a point where there's another number other than 1 and the number itself, it's not prime, but I will list the other factor for you as well at 5, okay, so 10 is not a prime number. Same thing with the next one, numbers that go into 12, okay, here are all the numbers that go into 12. So that one is not prime, they have too many factors. And the last one I have is 17. Well, I know 1 goes into 17. I know 17 goes into 17. Are there any other numbers that divide exactly into 17? No, there's not. And because then it only has those 2 factors, that one is prime. And there is a question that's just appeared at the bottom for you. I'll give you 5 seconds. If you want to pause the video, please pause it so you can have a go, and then I will go through that answer with you. Okay then, so if I go through, we've already mentioned the number 1. 1 is not a prime, it only has 1 factor, so that one is not. 2, okay, numbers that go into 2. So 1 goes into 2. 2 goes into 2. There's no other number that goes into 2. So yes, that is prime. That's my only even prime number that you will ever see. All the other even numbers will not be prime because 2 will go into all of them. Okay, so the next one is 9. Well, 1 goes into it, 9 goes into it, but also 3 goes into 9 as well. So that one is not prime. For 29, I have 1 goes into it, 29 goes into it, but there are no other numbers that divide exactly into 29, so that one is a prime number. And then the last one here, 1 goes into it, 49 goes into it, but also that is a square number, which means 7 goes into it. So 7 squared, as soon as I can see another value that goes into it, other than 1 in itself, it's not prime. So the answers you should have had there were 2 and 29. Okay, what you can see on the screen now is a list of all the numbers up to 100, and all the ones that are highlighted there are your prime numbers up to 100. Okay, so if you want to have a little glance at them, you can see the values there, and then I have listed them as well underneath as just a list. Okay, so the numbers that we have, it might be worth you pausing the video and writing those down. It can help you with the next little task that goes on the screen. Okay, so there are 4 questions you can see now. I'd like you to pause the video and have a go at working through those questions, and then I will go through them in a few seconds. Lovely. Okay, so I'm going to start to go over these questions. So we have fill in the missing numbers. The prime numbers up to 40 are, you could use obviously the table I showed on the last screen. You could work through them. These were in ascending order. So the missing values you should have had here are 5, and then 7, 17, 23, and then 37 are the missing numbers there. Question 2. Write down the only prime number between 90 and 100. Again, you could go back to the list or work through them. The only prime number is 97, and that was your answer for question 2. Question 3, how many prime numbers are there between 60 and 90? Well, the prime numbers are 67, 71, 73, 79, 83. I'm not sure why my pen went like that then. 83 and 89. So if I count those up, I have 7. So 7 was the answer to the question 3. And then I've already talked about question 4. So what is the only even prime number? It is 2. Lovely. Okay, so moving on now, we've completed the first 3. We're going to have a look next at factors and highest common factor. So factors I've already spoken about. Okay, so we've got a number that divides exactly into another number without leaving any remainder. And the example I showed on a couple of slides ago was the factors of 20. And we had them, all these numbers here are numbers that go into 20 exactly without leaving any remainders. The new part of what I'm going to show you now is the HCF that I've got as the title, and that stands for highest common factor. Okay, so the highest common factor of 2 or more numbers is the common factor with the highest value. So this will make more sense as I go through the example now. So we've got find the highest common factor of 16 and 20. Okay, so to begin with this question, you're going to start by listing the factors of each value. So the factors of 16, okay, are numbers that go into 16. Now, you don't have to write them in order. Sometimes it's easier to identify these factors as they come in pairs. But as we finish it off, then it's easier if we write them in ascending order. Okay, so I'm going to start off. I'm going to say, well, 1 goes into every number. So 1 is going to be in my list. And I'm going to think about what do I multiply 1 by to get 16? Well, it's 16. Okay, so number 1 and the number itself will go into it. They will be factors. If I go up from the number 1, the next value I come to is 2. 2 goes into 16 because 16 is an even number. And what do I multiply 2 by to get 16? I multiply by 8. So 8 goes into 16. If I carry on going through my number system, the next number is 3. Well, 3 does not go into 16 exactly. I will have a remainder, so that is not a factor of 16. So the next value I come to is 4. 4 does go into 16, and 4 multiplied by 4 is 16, which I've already got in this list. So I'm not going to write any more. And as soon as if you use this method, as soon as you get to a value you've already counted, then you know you've collected all your factors. But what I am going to do now is rewrite these from smallest to biggest, just because it's going to help me identify the highest common factor in the next step. Okay, so I've just rewritten the list, smallest to biggest, so it'll be easier for me to read. Okay, so then we move on to the number 20, and we list all the factors of 20. So again, I'm going to start on the number 1, and 1 multiplied by something is 20, that is 20. Going from 1, the next value I get is 2. 2 multiplied by 10 is 20, so 10 is also a factor. Then I come to the number 3, that's not a factor of 20, so I miss it out. Next number is 4. 4 is a factor, and 4 multiplied by 5 is a factor. And because now I've got to a value that I've already counted, I know I'm finished. I'm just going to rewrite these smallest to biggest. So 1, 2, 4, 5, 10 and 20 are my factors. So the new part of this now, which is the highest common factor, the HCF, is looking through these lists for the largest number that comes up in both. The word common means it has to be in both lists for us to work. If we go through these lists, 1 is in both, 2 is in both, 4 is in both, they're all common factors, but we have to list the highest one. So even though there's a few common factors, the largest, the highest common factor in both lists is 4. So I would write down HCF equals 4. Okay, and that question is now complete. If I carry on looking through the list, there was no other common factor, so I'm happy that I've got that question. Okay, so there are 2 questions on the screen. Again, pause the video, have a go at those. I will start to go through those in a few seconds. Okay then, so I'm going to start to go through them. So I would start by listing all of the factors of 18. So the numbers that go into 18, I'm going to write these in order straight away so you can check your answers. So 1 times 18, 2 times 9, 3 multiplied by 6 are all my common factors there. Factors of 24, 1, 2, 3, 4, 6, 8, 12 and 24. Okay, remember these come in pairs. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. They all multiply then to make an answer of 24. So you look through your lists, and like I said, it's much easier. If these are all in order, you can actually go from the right-hand side is sometimes better because you can work backwards until you find a number that's in both lists. And I can see here that 6 is my highest common factor. Even though 1, 2 and 3 are common factors, I have to have the highest one, which was 6. And then the final question here, so factors of 30. So you should have listed 1, 2, 3, 5, 6, 10, 15 and 30 for the list of 30. And then the factors of 45, 1, 3, 5, 9, 15 and 45. Okay, so all the numbers are divided exactly into those. And you can see the highest common factor then is 15. Okay, well done. Right then, so we're almost there. We've got multiples left to do. So this is what we're going to move on to now. So multiples. The multiples of a number are its times tables. So multiples sounds like multiply. So that's one way that you could remember the difference between factors and multiples. People too tend to get mixed up with the two. So just keep in your head the multiples are your times tables. It sounds like multiply. So for example, the first 6 multiples of 4 are 4, 8, 12, 16, 20 and 24. Now, because our times tables go on forever, you will be given, like this question says, the first 6 multiples. You're not going to carry on forever and write all of them down. You're never going to get to the end of the times tables. So you will be given how many you want to find, or perhaps a value or 2 values that you want to find the multiples between, and you go in to use that then. The LCM, just like HCF, stands for something. So LCM stands for the lowest common multiple. So the lowest common multiple of 2 or more numbers is the smallest number into which they will all divide exactly. Okay, so we're going to think about our times tables, and we're going to think about the smallest number that's common in the values that we're given. So for example, find the lowest common multiple of 3 and 8. So this would involve us writing down, and it's important, examiners will look for this, your times tables. So let's write down a few of our 3 times tables. So we start on 3, then 6, 9, 12, 15, and I don't actually know how far I need to go yet, so I'm going to stop there for a minute, and I'm going to move on to the 8s. So I'm now going to write down my 8 times table, and I'm going to have a look at what I've got. Well, nothing at all matches so far, and I've already gone past my last value in the 3 times table, so I'm going to go back up now to the 3 times table, and I'm going to carry on in the 3 times table and hopefully come across something that's common. And I can see now I'm stopping here because I have a number that is now in both lists. It's the first number I've come across that is in both lists. So that is my lowest common multiple. And so the answer is 24. Okay, so the smallest number that is common in both times tables is what you're looking for here. Okay, same as before, you can have a go at these 2 questions. If you pause the video and have a go, I'll give you about 5 seconds to do that, and then I'll start going through them. Okay, so lowest common multiple of 4 and 9. So you would start by writing out your 4 times table and your 9 times table, and then you're looking for a value that comes up in both lists, and it's the first value you come to. So if I write down my 4 times table, it is 4, 8, 12, 16, 20, 24. And again, I don't know how far I'm going to go, so I'm going to stop. I'm going to start on the 9s. So 9, 18, 27, 36, 45. Could keep going. Again, I'm going to go back up now and do a few more on my 4 times table. I still haven't got to a value that's in both lists, so I've got to keep going. And now I have, so 36 is my lowest common multiple. And then you repeat the process then for question 2. So I've got 5 and I've got 12. So I'm going to write down my 5 times table. And I'm going to stop there for a minute. I'm going to go to my 12s and write down the 12 times table. So 12, 24, 36, 48, 60. And I'm going to go back up to here. I'm going to carry on. I still haven't got there, but if I keep going a little bit more, I can see that 60 is going to be my lowest common multiple. So check your answers, have a look at what you've got there. Right then, so we've covered our 5 topics. So what I want to look at now are a few GCSE questions based around the 5 topics that we can see here. First one, okay, choosing only from the following numbers. So here's our list of values. Write down a square number and then a multiple of 7. So these were 1-mark questions. It was a case of looking through the list, trying to identify and remember what these meanings were. So if we think back right to the start of this session, we started with square numbers, and square numbers were the answer you got from multiplying a number by itself. So things like 1 multiplied by 1, 2 times 2, 3 times 3, 4 times 4, the answers you get from working those through. So if I go through this list, what we're looking for is a square number, and there's nothing at the start. 22 is not a square number, 27 is not, 29 is not, 34, 35, no. The answer you should have had here is 36, because 6 multiplied by 6 is 36. Question 2, a multiple of 7. Well, a multiple is what we've just done a couple of minutes ago. That is your times tables. So we're looking for a number that is in the 7 times table. So it might be helpful that you actually write down your 7 times table until you find something that in that list above. So there's nothing so far. So I've got to carry on, and I can see now I've got a number. It's there, it's 35. 35 is in my 7 times tables, so I would use that as my answer. Okay, moving on. With any of these questions, obviously you can pause the video and have a go at these yourself before obviously I go through the answer. If we remember, this little tick symbol with the little 3 next to it means cube root. So again, this is a 1 mark GCSE question, and you are looking for the answer you would get if you times a number twice by itself to give you 8. And that number was 2, because 2 multiplied by 2 is 4, multiplied by 2 is 8. So because when I times it there by itself twice, you get 8. The answer there for the cube root is 2. Okay, then we are going to now look at some worded questions. So we have a picture of a drum and a triangle at the top. So in a school band, Eva plays the drum and Gethin plays the triangle. In a particular piece of music, Eva has to beat the drum once every 6 seconds, and Gethin has to hit the triangle once every 8 seconds. They both play their first note at the same time. How many seconds are there until they next play their notes at the same time? So we need to pick out our key information first of all. So we're going to look through this and say, okay, so the first line, they're telling us what instruments to play, but that's okay. The next bit is important. So Eva beats the drum every 6 seconds. Then Gethin hits this triangle every 8 seconds. They both play their first note at the same time. Okay, so first note at the same time. And then how many seconds are there until they next play their first note at the same time? Not the first note, sorry, the next note at the same time. So this is a multiples question that is hidden. It doesn't say use the lowest common multiples, but that's what it is. So we are going to write out Eva, and we're going to tell the examiner what we're working through at the same time. So when they first start, they are going to begin on 0. Okay, they're starting, the time is starting, and then the first time Eva beats her drum, it is 6 seconds in. She next beats her drum 12 seconds, and then 24 and 30, and obviously she'll keep doing that every 6 seconds. Gethin, however, when the timer starts, he's on 0, and the first time he's going to hit his triangle will be after 8 seconds. 8 seconds, another 8 seconds is go. Sorry, I'm saying 8 because I'm writing it there. 16, then 24, and I'm going to stop there. And because I can now see, just like our lowest common multiples that we wrote down earlier, lowest common multiple here is 24. So I would be writing 24 seconds is the next time they both play their instrument at the same time. They play at the same time. Okay then, so we've covered obviously 5 sort of key topics there, and we've covered a couple of the GCSE questions towards the end as well. So what I would like you to do to just finish off, it's a task again you can pause the video for. It's just a quick matching task where on the left hand side you have a statement. So we've got prime number, factor, multiple and common factor. And then on the right hand side then we have a definition, and it would just be a case of you matching them up for me. So I'll just give you a few seconds to pause the video, and then I'll quickly go through those answers to finish off. Okay then, right, so prime number. So when you read through the statements, if you think back towards the start of the session, a prime number is a number, it has to be greater than 1, okay, but it has 2 factors, and exactly 2 factors, the number itself and the number 1, so that should be matched to the third one down on the right hand side. The word factor matches to the numbers that divide exactly into a given number. so that matches to the top one. The words multiple are numbers that appear in your times tables, so that matches to the second one, leaving then obviously the common factor matching across the bottom, so a number that can be divided into 2 or more numbers exactly. So thank you very much, and I hope to see you soon. Bye everyone.